Hello, Keith Rucker here at VintageMachinery.org. Guys, today I'm out at Georgia Museum of Agriculture, and we are going to be doing some work here on the 1917 Vulcan Ironworks steam locomotive that we've done a lot of work for in the past. Back about almost a year ago now, back last fall anyway, I had started on making some new bearings for the connecting rods for this locomotive, and my goal was to get it done over the Christmas break last year. Well, with things going on out here at the museum, they were not shut down as long as I thought they were going to be, not needing the locomotive, and we just didn't have a window to get them put on. Now we've rolled around to August, the month of August. The museum kind of shuts down for a month, and that's really kind of our go-to month to do maintenance stuff on the locomotive. So we're going to be doing this project right now during this month while they are shut down, and we can get in here and tear things apart without taking the locomotive out of service. So today I'm going to be pulling the connecting rod off of one side here. We're going to be taking that back over to my shop, and then we got to finish machining those bearings and get them put back on. I got to do both sides, connecting rods on both sides, but we're going to do one side at a time until we get these things done. So let's come in here. I'm going to show you the process of pulling this connecting rod off, and then we'll get it in the shop and get to work on it. So just taking a look here, this is the rear wheel. I'm on the left side of the locomotive. This is the front wheel, and there's actually two connecting rods. One connecting rod goes here to the steam engine that goes back and forth. It goes back here to the back wheel, and then there's an inside connecting rod in there that connects that to the front wheel. And the one we're going to be working on is that inside connecting rod. That's the one we got the new bearings made for, and we need to pull that connecting rod off. So if you get in here and look at it, basically there's some bolts that go down through there. There's a strap that holds that brass bearing in there. You'll see it as we take it apart. So let's get in here and get this thing out of here. Alright, so we got to start by taking these bolts out here. These are actually tapered bolts. At least they were when they were new. We're going to be making new ones and trying to fix all this. But there's a couple of bolts holding this strap in the top. My word. That's tight. Got it. I got it. This will work. This will work. That should drive out.
Move it over to your right, dude.
Yeah. Can you pick it up a little bit?
Take over that. Bolts. You want to put all the bolts in here?
Yep. We got those.
In there. got it all off.
There we go. All right, you can see that journal here. That's the what we're going to have to bore those bearings out to match up to, and we basically are just going to come out here and measure these. I forgot to bring my micrometer, but we're going to get these measured, and we will actually turn these to fit. They're going to just be whatever they are. They're probably all going to be different because this machine, this locomotive, has worn for over 100 years, so they probably are all different. But that's fine. We'll make them fit. So I got the one on the front, same way. Well, guys, I got all the parts off the locomotive. We got them into the shop now. We can really start working on getting things going. And if you guys have been around for a while and been watching the channel, you remember about, I don't know, this last winter, about 8 or 9 months ago, we were working on these bronze castings that were going to be the new bearings for these connecting rods. And like I think I said earlier, I was trying to get this done over Christmas this past year when the museum was shut down, and we had to switch gears and get on a different job, and this kind of got put on the back burner. Well, they're shut down again in August, so this is our window of opportunity to finish these bearings up. So I've got the original bearings here, and we got the new bearings. We got to finish machining these, primarily boring out the hole for that's going to fit up onto the stud on the wheels. I've got the measurements on those. I went back out there with a micrometer and I mic'd them all really good, and I got the measurements on what the bore size needs to be, and we need to go ahead and get set up to do this. So let me kind of zoom in here. I want to show you these old bearings and compare them to the new bearings and see how much wear is really in them. So this is our new bearing. It's basically made right to the blueprints, which I've got the original blueprints for these connecting rods. So we've taken them back to the original design, and they pretty much match these, but you can see these are a good bit shorter. And the reason is because they've worn in here over the years. And these bearings are designed where as they wear, you can tighten them up and keep using them. But we're getting thinner and thinner and thinner on these walls in here, and we're running out of material on these bearings, which is why it's time to go ahead and get them replaced. So you can see, you know, if we just take them out to the ends, you can see the gap in here. You know, that's about how much these bearings have worn, that particular one there. Significant over time. It's still good, and we could continue using it, but again, it's starting to get a little bit thin in here in the backs and running out of material, and it's time to go ahead and get some new ones on there. So our castings that we had done, this is just a rough casting on the inside. It's just a cored out hole. So we need to get that bored out to the proper size and in the proper position. We've already got pretty much the rest of our machining done on these. Same thing over on the other bearing on the other end. It actually doesn't have quite as much wear on it, but you got a bigger journal, so there's more bearing surface, so it makes sense that this one would probably wear a little bit slower, but still starting to get kind of thin in there. So it's time to get these knocked out. So what we're going to do is we're going to take these over to the milling machine. We're going to get set up to bore this hole out. Like I said, according to the blueprint is one side. The blueprint says what it was originally, but we need to bore these out to the actual size that's needed. And as you can imagine, with the locomotive that's got over 100 years of use in it, that pin that this is riding on has also worn down. And based on the original measurements and where we are, they've worn down roughly 100 thousandths in diameter. Like, not a big deal, and we can work with it. No need to have to go in there and build those back up. They're still plenty strong enough. There's no problem with it. We just need to make these fit what's there. So these will be bored according to fit rather than to the blueprint, because the blueprint was for a brand new locomotive. All right, let's get these set up and do some boring. We're going to bore these out over here on the vertical milling machine, and I'm just going to use a boring head in here to actually do this with. So I'm going to go ahead and get this changed out, get the boring head in here. We'll get our work set up in the vise. Going to have to do some measuring to get it set up to find the center of where we need to get our bore bored out at, and then we'll start the boring process. So let me get this tool in here. So this boring head basically has 3 places in the bottom that you can put a boring bar into. I'm just going to put it in one of the, think we can probably swing on one of the outside ones here. So I'm going to go ahead and put this in, get a set screw there. So we'll go ahead and tighten this one up. There's actually 3 places on the bottom that you can put one of these little boring bars, and this kit comes with different boring bars. You can also put them on the end sticking straight out if you got a really big hole you need to bore out. And the way this works is you got this little adjuster on the end, and when you put it in there, you can rotate this. It's calibrated. It's got thousandths of an inch on there where you can do it, and you just expand this thing out, and it's going to swing a circle around and around and around, bore it out, and then when you get ready to go on your next one, you just move it out however far you want to move your next one out, and you keep doing that until you get your part to the size. So anyway, there are some gibs on the front. You can tighten these up. Once you kind of get it to the point you want to go, you just tighten these little screws up, and that keeps it from moving around. Pretty simple setup. So now I want to get my work mounted in here. First off, just kind of make sure my bottom in here is clean, don't have any chips. I've got a couple little spacers I'm going to set this on because the boring bar needs to come all the way through, and I don't want it to hit the vise. So I'm just kind of sitting it up off the bottom a little bit, and we will set our work down in the vise. Yep, I'm off those blocks, so I got plenty of clearance room, and we'll tighten that down. So the side that is down, I had marked, I had to put an X on it. That just was my reference face, so that's the side I want to be putting down. That's the side I was always kind of referencing off of, which should be where everything's parallel and straight with that side. Next thing I need to do is actually find my centers. And I'm probably going to have to actually take the boring head back out and put an edge finder on here to do that. I wasn't thinking ahead far enough. So let me do that. We'll locate where the center needs to be, and then we'll put this back in and go ahead and start boring it out. What I need to do is I need to find the edge over here. And according to the blueprints, the center of the hole should be 2.5 inches in from the end. And then the center of the hole in this direction is going to be just the center of this piece. So we need to find this edge, then come in 2.5 inches, and then we need to find, basically we'll find both edges and then to take half of that value, and that'll put us into the center. So let's go ahead and fire up the milling machine. I will come over with my edge finder. When that edge finder kind of scoots over, we're parallel with the edge. I'm going to zero out my digital readout. I'll just verify that number. I like to, yep, very good. So now I know that this is 1/2 inch, so I need to come in 250 thousandths to basically get off of the edge to get onto the center. So I'll just read that directly on the digital readout. 250 right there. I'm going to zero out my digital readout. So now the center of the spindle is right over the center of the edge here, or the edge. Now I need to come in 2.5 inches, and I'll just measure that again using the digital readout, and that'll get me center in that direction. So let's see here. Right there is 2.5 inches. So I'm going to zero that out now. So if I need to come back to it, I can. Now we'll find the edges here and find the center in that direction. Right there. Zero out the digital readout. We'll verify. We're good. I zeroed out on that side, so we'll come all the way to the other side here. Find this edge. Right there. I'm going to double check my measurement. Same number. Okay. Now I'll just use the half function over here. I'll find half of whatever that measurement is, and that'll put me in the center. So let me do that real quick. Take this to 0 on the digital readout now. All right. That is where we need to be. That is right in the center of the hole. That's where we need to bore our hole. So let me get my boring head back in and we can get ready to start boring. All right, I think we are set up and ready to go. I've got the boring bar, boring head set up where I'm just hitting a little bit down in here on this first pass. This is a rough casting, so it's gonna be a little bit rough on the first pass. And I'm gonna set my feed rate to 3 thousandths per revolution. So every time this head goes around one time, it's gonna feed down 3 thousandths once we get it going here. And it should just bore all the way down, and it's gonna probably be just skipping around a little bit at first until we kind of get it cleaned up and a good circle all the way around, and then we will bore this out to the size, and the size we are shooting for is 2.410 should be where we want to be at. 2 inches, 410 thousandths. Our cored out hole here is about 225 thousandths, so about 2 1/4 inches. So we've got not quite 200 thousandths to come off the diameter. All right, we will turn our boring bar on, and I am going to engage the down feed, and we're just going to kind of let it go down. Again, it's not going to be touching all the way down. That hole, because of the casting, has draft to it, so it's tapered. It's thicker in the middle than it is on the top and the bottom. So until we kind of get it cleaned up all the way around, it's not going to be making an interrupted cut, but it'll be fine. We'll just let it go on down through there until we get a good bore going. All right, we're starting to hit a little bit in there. I just kind of set it where it was just barely going to touch it on this first pass, hopefully. Once we kind of get our first pass through there, we can dial in and start making a little bit heavier cuts. But I always want that first pass to be a little bit conservative because it's regular around. It's not making a uniform cut. So we want to kind of ease into it. And I believe that is it on the first pass. We'll come up. We will stop. And I want to feed it out. We're going to go, let's see here. I want to go about 25 thousandths there. And we will make another pass. Again, it's not going to be cutting the whole way down, but as we get down in there, it'll start cutting out again. And we're just going to keep doing that until we get a good bore all the way through. Fine. All right, guys, I did change out my boring bar. This one was, once it got down to the bottom, it was rubbing up here on the top. So I just went to a little bit longer boring bar to fix that. But we are making progress here. I'm going to actually increase my bore or my cut from 25 thousandths to 50 thousandths to see if we can go a little bit faster. It seems to be going pretty good. So yeah, that's cutting just fine at 50 thousandths. So I will note that the cord hole here wasn't exactly in the center of where we need to be. It's going to all bore out just fine, but we're cutting on this side. We're not even quite touching it on this side, but we still got a ways to go. By the time we get over here, it'll be cleaned up all the way around. But anyway, we're making progress. All right. Cleared out. Let's see if we can get this in here and measure this. All right, this is reading 375, 85, 95, 96. 2.396 is where we're at right now. So I need 14 thousandths to get this to size. So I'm gonna dial that in. It's been boring pretty true, so I think we'll be fine here just to go to the final measurement. And we will make one more pass down through here. I'm gonna change, I've been going at 6 thousandths per revolution. I had it on 3 originally, but I did speed it up. I'm gonna go back to 3 for this final cut though, just to get a little, hopefully get a little smoother cut. But this should be our final pass. Just taking a look down in the bore there, you can see that we're making this final pass and cleaning up real nice in there. Drop my table down a little bit to get the mic down in here, I think. There we go. And look at there. I was shooting for 2.410 and can't get a better number than that. All right, we were shooting for 2.410, 2.410. There's 2.4, and we're at 10 thousandths, and this reads to 2/10. I mean, we're dead nuts right on it. So I don't know that I needed that level of precision, but I got it. Love it when it hits it just right. All right, we're gonna pull this one out. It should be all finished up, and we'll get set up with the second one to pour out. I've got my second bearing block over here mounted up. We've already found the center of the hole where it needs to be, and we're in the process of boring. I've made one run down through it already. This one is the rough hole is a lot closer to center on this one than the other one was. It was fine on the other one. We had plenty of material, but this one seems to be a lot closer to where it's in position. So anyway, we're on our second pass down through here and got a little ways to go, but same process as before. We're just going to get this hole bored out to size. This one is going to be 3.430. 3 inches, 430 thousandths. So anyway, I'm not going to bore you guys with this too much. You've seen the process. We'll get this one bored out, get it checked out here in a little bit, and hopefully have the boring done. So I've been doing a little testing here, test fitting these bearings in here. So this bearing is going to slide up in this strap like such. It's going to rest up against this back here. This, of course, will be split, as you can see with the other one. Eventually, we're going to cut these in half, or it's 2 different halves, and they'll be in a wedge on the front side up here that will correspond with the angle in here that you adjust this up and down, and that will adjust how tight this goes. This back one just basically sits up against this back piece, and then you can tighten this up, and that will wedge it forward to adjust for wear. As it wears too, you also have to shim behind these to keep the spacing right. And so there was quite a bit of shims in the old one. Of course, we shouldn't need as much shimming in the new ones going forward. So you can kind of see we got that slope in here that matches the slope on the wedge. These slide on top of one another, so there's an adjusting screw. So as you move this up, it pushes the wedge in. Just a little wedge adjustment. All that fits real well. The one thing I've got to do to make all this work is, if you look on this bearing, there's a radius in this back here, and there's a corresponding radius that is ground, milled, whatever, into the brass. On our new bearing, we pretty much have a straight 90-degree corner in there. I need to get that radius put in there. And instead of trying to machine it, guys, I mean, I could set up this super complicated set up on a rotary table or something like that to mill those radiuses. It's just for clearance. I'm just going to grind them in there. I'm going to use my belt grinder, belt sander, and we're just going to put a radius on them, and should hopefully get the job done. This doesn't have to match it perfectly. I just need clearance, and they're really more interested in this back than I am in those radiuses. So let's go over to the belt sander, and we'll do that. When I made my road trip out to California a month or two ago, I picked up this really nice Ameribraid belt sander, brand spanking new, bought it from the factory, literally picked it up at the factory where they make them while I was on that trip. And we're going to use this. I'm going to kind of just take this table and just rotate it out of the way. We're not going to need it. I do need to change belts. I'm going to put a more coarse belt on here to do this grinding to make it go by quicker. I've got a 36 grit belt here. So we'll get this set up on here. There we go. And we're just going to tape these in here and grind a little radius on those edges. As I'm grinding these, I need to check that radius to make sure I'm getting the right radius. So I've got a radius gauge set here, and this is a 1/2 inch radius. That's a 1/2 inch radius in this tool, and that matches that pretty darn close. So now I can kind of come in here with this tool and check my radius compared to what I'm grinding here. And I'm not there yet, but that'll just kind of give me something to go off of. All right, I have got those radiuses ground in on both sides here. If anything, it's a little bit larger radius, which is fine. I'd rather have a little bit extra clearance in there than not enough. And now, see, this goes in this way. That slides in nicely, and you can feel it going right up against that back. And we got room for our wedge to drop in down here on the front. There'll be a screw right here to adjust the wedge in there. We'll have some shims in there to help get that lined up exactly where it needs to be. I may need to make a new wedge now that we've got one that's the proper size. I think that the wedges before we had made a little bit oversized just because to make them fit better, but we'll see. We'll see when we start putting it all together. But there you go. I believe that bearing is all fit up. I got to do the same thing to the front bearing. However, on the front bearing, let me show you this. I said front bearing, I meant big bearing, but this is for the larger of the two bearings. And it also has the radiuses in here. However, on this side, the adjusting wedge actually fits into those little grooves, so we don't have to worry about grinding that into the brass. The brass will it'll just fit right up in there, and when you'll adjust it just the same, but it adjusts on this side of the bearing, whereas the other one adjusts on the other side of the bearing. That's to enable you to adjust them to get them the right distance apart, being able to adjust them on either side. All right, I need to do my test fit, make sure everything's going to fit up in here just right, but this one shouldn't require a whole lot to get it ready to go. All right, this one fits right up on there, just like we need. I think we're just about through with these. What's left to do is I need to drill a hole up in the top of this. That's just going to be for oil to go down in. We've got the little oilers on the straps that keep these things lubricated. And then I'll take this to the bandsaw, and we're just going to split these bearings into half. So that we'll make two pieces out of them. Just cut them right down that line. Get that done, and I think we'll have the bearings knocked out. We'll be ready to start trying to get these things assembled and put together, which is going to be a whole other process in itself. Got this over here in the drill press. We'll go ahead and just drill these holes out. Put this over in the bandsaw. go around here and sand all these, deburr everything, make sure we got it nice and smooth, no rough edges. And with that, I believe we have these bearing halves all finished out. These are ready basically to be reassembled. And coming up next is going to be the job of getting things kind of reassembled and put together and building these, this whole connecting rod out, getting it properly spaced, etc. Before I can do that though, one of the things I want to do is I want to replace all of these tapered bolts. We're going to re-ream these out to clean them all up and get them like they need to be. So that's going to probably be the next step, is getting all these new tapered bolts made, and then we'll start building out the connecting rod, getting it all spaced properly and reassembled back on the locomotive. Well guys, there we go. I think we got these knocked out. And like I said, we'll be continuing on. This is going to be some more work to get these connecting rods all finished up. But we are making good progress. I'm glad to finally have these steps knocked out. A long time overdue, but like I said, we just needed to have access to getting the parts off the locomotive, and we just weren't able to do it until now while it's down. But we are going to get this knocked out. Hopefully get this back up and running here pretty soon, because we're going to be starting up running the locomotive again first part of September. And need to have these ready to go. So with that, we're going to sign off for today. As always, thanks so much for watching. Please do subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted to the site. And as always, a big, huge thank you to those who support the site financially through Patreon, PayPal, etc. Really enables me to take the time to be able to shoot these videos and bring them to you guys. And with that, we will sign off. We'll catch you on the next video. Again, thanks for watching.